Okay, so here we go with lesson 5. We're going to start to solve inequalities and understand what that means to do that. So recall from last lesson that inequalities have infinitely many solutions. Therefore, to show all the solutions, we have to graph the inequality. So when we are solving the inequalities, we are not finding the solution. We are finding the boundary between the solutions and the non-solutions. So on one side of the number is the solutions, and the other side is the non-solutions. Make sure you understand that difference between equations and inequalities. In an equation, when we solve it, we're finding the one solution. In an inequality, when we solve it, we're finding the boundary. Okay? In other words, the number we find after solving is the number that separates the solutions from the non-solutions. This number is sometimes a solution and sometimes not. Hopefully you can figure out when it is and when it is not. But if you can't, let me show you. Those two means that the number is not equal to. So in this case, it would not be a solution. The boundary would not be a solution. In this case, it would be a solution because the left side would be equal to the right side. Okay? And we'll look at some of those as we do several examples in this lesson. To show all the solutions to the inequalities. The good news is you're doing the exact same thing you did with equations. You're getting the variable by itself. That's it. But the interpretation at the end is what changes. So x is less than -4. Again, that's not the solution. That is the boundary. So I'm going to graph this. Here's 0. -4 is to the left. I'm going to try to stress using the stress point, or sorry, the test point, not stress point. I'm going to, again, use 0. So I'm going to put 0 in for x. Is that a true statement or a false statement? Is 0 less than -4? No, it's not. So I'm not shading towards 0. I'm shading away from it. Open circle, shade away. Next one. Change colors here. 8x is greater than or equal to -40. Now, some of you have dealt with this before, and you think, oh, I must flip the sign here. Well, in fact, you do not. -40 divided by 8 is -5, and I'll talk about why here in a little bit. Here's 0. -5 is to the left. It's a closed circle this time. And I'm going to again use the test point of 0. Is 0 bigger than or equal to -5? Yes, it is. So I'm going to shade towards 0. All right. Last one. In the first round, I'm going to divide by -2. And in dividing by -2, I am going to flip the sign around. Notice how it went from less than or equal to greater than or equal to. The graph, -7 again is to the left. Closed circle again, because it's an equal to. Test point, 0. Is 0 bigger than or equal to -7? Yes, it is. So I'm going to shade that way. So in number 2, I didn't flip the sign, but in number 3, I did. When do you flip the sign? Well, you flip the sign when you multiply, when multiplying or dividing both sides by a negative. One thing a lot of people think is if the answer is negative, the sign flips. No, it does not matter if the answer is negative or positive. That has no bearing on whether you flip the sign. If you look at number 2, the answer was negative, but I didn't flip the sign because what did I divide by? I divided by 8. In number 3, I divided by -2. That flips the sign. Multiplying does the same thing. So real quick, I'll show you. X divided by -4 is greater than 10, or I'll even say -10. I'm going to multiply both sides by -4. That flips the sign. -10 times -4 is +40. Yes, the answer is positive. Doesn't matter. I multiplied by a negative, it flips the sign. Let's do some more practice. Number 4, variables on the right-hand side this time. Makes things a little tricky if you try to use shortcuts. I'm going to add 7. 1 plus 7 is 8, is greater than x. 0 in the middle, 8 is to the right. Open circle here. That's not equal to. I'm going to use test points again. 8 greater than 0. That's a true statement. So I'm going to shade towards 0. Okay. Next one. I'm going to subtract 8. I get negative x divided by 3 is greater than or equal to 2 minus 8 is negative 6. I have a negative and a 3, so I'm going to multiply by negative 3. In multiplying by negative 3, it flips the sign. Negative 6 times negative 3 is 18. Circle open or close circle here, because it's equal to 0 is less than or equal to 18. That's true. So I'm going to shade towards 0 again. Last one here on the front, minus 3. I get 12 is less than negative 2x. Divide by negative 2. I get negative 6. The sign does flip, and I get x. Again, this is why I don't like to move the variable to the left, because if I move the variable to the left, I'm actually flipping the sign again. It looks weird. It starts getting confusing. This is why I like the test point better. Open circle here. I'm going to put test point of 0 in. Is negative 6 bigger than 0? No, it's not. So I'm going to shade away from 0. And that is the front. Let's work on the back where there's a little more complex problems. Same thing that we've been doing though, except it's just a little more complex. All right. So I'm going to get rid of the fraction by multiplying by 6. Not negative 6, so no need to flip. So 5x plus 12 greater than 42. Subtract 12. 5x is greater than, make sure you don't change the sign. I see a lot of people switch that to an equal sign. Don't do that. Or I see people add an equal sign when it wasn't there. Don't do that either. Divide by 5, I get x is greater than 6. Should be pretty easy to graph. Do it real quick. Open circle. Is 0 bigger than 6? No. Shade away. Next one has the distributive property in it. So I'm going to distribute the negative 2, just like we did with solving equations. So 5, negative 2x, negative 2 times negative 10 is positive 20. 5 and 20 makes 25. Minus 2x is greater than or equal to 13. Subtract the 25. I get negative 2x is greater than or equal to negative 12. No sign flip because I've just subtracted, but now I'm dividing by a negative, and that does flip the sign. So it's going to be less than or equal to negative 12 divided by negative 2 is positive 6. Close circle this time. 0, I'm going to put it in. Is that a true statement? Yes, it is. So I'm shading towards 0. Okay. 2 more. And as you've probably noticed, they're getting a little more difficult. But the interpretation at the end is remaining the same. You've done all these before. Distribute the 2/3. 4 is less than or equal to 2 times 9x is 18x. 18x divided by 3 is 6x. 2 times negative 15 is negative 30. Divided by 3 is negative 10 plus x. So 4 is less than or equal to 6x plus x is 7x minus 10 plus 10. I get 14 is less than or equal to 7x. Divide by 7, I get 2 is less than or equal to x. 2 is to the right, close circle. I've been doing test point on all these examples. I'm going to try it. I'm going to show you the other way I like to do it as well. Pick a number that works for x. So a number that works for x would be, other than 2, 3 would work, right? 2 is less than or equal to 3. So 3, I'm going to shade towards 3, which is to the right. Okay, find the way that works for you and run with that. Hopefully it's not the shortcut because I don't like it. All right, so I'm distributing a -3. -3 times 2x is -6x. -3 times 7 is -21. 5x minus 6x is -1x minus 21. Add 21 to both sides. I get 101 is less than -1x. Divide by -1. Yes, we're still dividing by a negative. So I get -101. Flip the sign and x. So -101 is greater than x. -101 is way over here. Open circle. And what's a number that would work for that? Or let's do that. What's a number that would work for that? -101 is bigger than, oops. It's bigger than -110. So I'm going to shade that way. Okay, that's solving inequalities, which the new part was interpreting your solution and what your solution means in the context of inequalities. So that's it for this lesson. We're going to go to a little more advanced ones in the next lesson, and then we'll do some word problems.